Hi there, this is Miss Gallant. I was not feeling 100% about this unit, or this topic so far. So what I wanted to do was film myself working some of the majority of the study guide so that you kind of had this option to help you guys out. So we're gonna I'm not gonna work the entire thing. I went through and looked at the quiz and looked at the study guide and picked the most important questions that I felt you needed my help with. Now there are some important questions that I think you've got on your own, but the ones I figured you needed the most help with, I went ahead and highlighted so I can help you with those. All right, so let's look at number 1. We have this figure, and this is our pre-image, and we are going to transform it according to these rules, and we're going to label each transformation as rigid or non-rigid. So first thing I want to do is get the coordinates. So let's call this coordinate A, coordinate B, and coordinate C. So A, B, and C, we're going to label here. All right, so the coordinates of A, here's 0, 0. It's 1 on the x-axis and 1, 2, 3, 4 on the y. Coordinate B is negative 2, negative 2. And coordinate C is 1, negative 2. Okay, so the first one I have highlighted, we are going to take each of these coordinates, we're going to add 2 to x and subtract 1 from y. So I'm going to do this in blue. Okay, so if I add 2 to 1, we get 3. If I subtract 1 from 4, we also have 3. Okay, I'm going to do that with these two as well. So negative 2 plus 2 is 0. Negative 2 minus 1 is negative 3. And 1 plus 2 is 3. Negative 2 minus 1 is negative 3. So 3, negative 3. All right, and I'm going to go ahead and graph that over here. So we have 1, 2, 3, 3, 0, negative 3, and 3, negative 3. Okay, so if I take a look from this triangle to this triangle, it slid 2 to the right and 1 down. So every single vertex, every single point slid 2 to the right and 1 down. So the size and shape did not change. So this is rigid. So this was just a translation, so it's rigid. Now let's look at number 2, or the second one I've highlighted. You can do these two on your own. I have full confidence in you. Okay, so we're going to take the x, multiply it by 2, and add 1, and then we're just going to add 1 to the y. So if I do that, my new coordinates should be 2 times 1 is 2, plus 1 is 3, 4 plus 1 is 5. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. Negative 2 plus 1 is negative 1. And C, 1 times 2 is 2. And 2 plus 1 is 3. And negative 2 should be negative 1 when we plug it in. All right, so we'll go ahead and graph that over here. So 1, 2, 3, 4, 5. So we have a coordinate 3, 5. 1, 2, 3, negative 1. And we have a coordinate at positive 3, negative 1. All right, so if we look at this one, this in purple has stretched pretty far, and only like the height is the same, but the width is much different. We've because we've multiplied, it stretches the figure, so this is not rigid. Okay, full confidence you can do these other two. So these end up not working. All right, or this one ended up not being rigid, this one ended up being rigid. Okay, I'm gonna skip 2 because I feel like you can tell me how we got from here to here. And it should be a translation. Although I'm sure you could do a rotation or a reflection, but let's keep it at a translation. And make sure you write it as a mapping and in geometric notation, which we'll just write it in translation notation, where you have your t and how far you translated. Okay, let's look at 3. What is the image of -6, 3 under this translation? So this is our pre-image, and we are putting it into this rule, okay? Which I think you are pretty okay with. So we would just plug in x and y. -6 plus 5 is -1. 3 minus 3 is 0. So we went from -6, 3 to -1, 0. All right, B, what translation takes us from this point to this point? So we are trying to figure out this rule. How did we get from here to here? So what can I do to -6 to get to 0? Well, I can add 6. So we're adding 6 to x. And then how do I get from 3 to -2? Well, if I subtract 3, I get to 0, and subtract 2 more, so that's subtracting 5. All right. So let me write that correctly. We're going to do xy goes to x plus 6, y minus 5. And then if we want to do it in geometric notation, that is that t translation. So we're translating, which means t. And we are translating, we're adding 6. So we're translating to the right 6 and down 5. So we're going to do 6, -5. Okay, and that's all we need right there. I just need to see that it's a translation and which way it's going. Okay, number 4, translating with a directed line segment. So I mistakenly thought that we did not have to do this. It's not, it's actually not very difficult. I am just kind of upset with myself because I just did not compare the quiz and study guide to what I was teaching, and I took that out just thinking, oh, we don't need to do that, and I was wrong. So I apologize. So what we're going to do with this, we are going to, so it's translate along the line segment XY. So I'm used to calling this vector translations on a grid or just directed line segment on here. So we want to basically take the point X and drag it to Y. So this would be a patty paper exercise. So we're going to trace this. And this is X, and this is Y, and this is Z. And I want to make sure, I want to slide it so that X ends up on Y. And then we're going to do our best to kind of get this on the paper. So I'm going to actually poke a hole through. And I'm going to poke a hole through this one. Okay. So X went to Y, Z went to here, and Y went to here. So I'm going to trace this as best I can. So directed line segment, we are basically just going from X to Y. or whatever your segment is. Okay, and then I'm going to make sure I label this correctly. So x prime, y prime, and z prime. Okay, and then it says write the translation in geometric notation. So we're going to do along the line xy. So we are going to, down at the bottom, put ray xy. And that shows me that I'm going along x to y. And then we're also going to put in parentheses what we actually translated. So we translated triangle XYZ. Okay, I'm going to let you try B on your own, but you are going from X to Y, so you are going to drag X. You're going to follow the line down to Y. Okay. Whew, trying to get this thing off my paper. Okay, so I'm going to let you try this one on your own. So just remember, just drag from X to Y. So you're going to take your patty paper, trace it, drag from X to Y, and then make sure that you have this written in geometric notation. Okay, so number 5, what translation will translate the left figure onto the right figure? So this is one that you actually don't need anything for. We're just going to talk about this one. Basically, I'm dragging from C to C prime, right? If I were to copy this, I'd basically be dragging it all the way from this point to this point. So all we need to do is say that we are taking figure, or we're going from C to C prime, and we are translating figure RSTUW. And just so you know, when you name your figures, you don't just willy-nilly them. You start at 1 and then work all the way around. You don't just go RSWUT, like you go all the way around. So start at 1 and go around. Okay, so this is it. This is the answer. I can think of one on particular on the quiz that looks similar to this. Now, here's the thing. If you had seen R prime or S prime or U prime, you could have said, oh, I'm translating from R to R prime, or from S to S prime, or whatever the case may be. You can use any point to any point, because R should translate to R prime, C should translate to C prime. So this should be fairly straightforward. Now, if I had different letters, you could, let's say that this was a Q. We could have said from W to Q, or whatever the letters are. All right, so that's page 1. Less than 15 minutes on page 1. That's a record for me. I'm notorious for long videos and drawing them out longer than they need to be. Okay, let's look at number 6. Sorry for the glare. So we have a diagram here. 2 of the triangles represent the translation xy to x minus 4, y plus 5. So let's talk about what's happening here. This x minus 4 tells me we are going to the left 4. Y plus 5 means we are going up 5. So which figure is the pre-image and which figure is the image? So we want to see which triangle did we take to the left 4 and up 5. Well, C is already on the left all the way, so we didn't translate this. B is already up, so we didn't translate this, so A has to be the pre-image. Okay, so which figure is the image? Well, let's see. If we go to the left 4, 1, 2, 3, 4, and up 5, 1, 2, 3, 4, 5. The top point of A maps up with the top point of C. So we are going from A to C. Then it says, what translation will take you back to the pre-image? So if I'm starting at C, what do I need to do to get from C to A? Well, let's look. To get from A to C, we went to the left 4. So to go back, I have to go to the right 4. I went up 5 to get from A to C. To get from C to A, I have to go down 5. So we will write this as xy. To go back, we are going to go up 4 and down 5. It does say geometric notation, which I've always called just transformation notation. So this is that T. We went 4 to the right, 5 down, and we are translating figure C, which maps us back to A. All right, number 7. We have a point located at -4, 5. What reflection maps the point to 10, 5? So let's look at what changes. The y's stay the same, but the distance -4 to 10, the x values changed. -4 went to 10. So what we're going to do, if you remember, when we had something reflecting, so I'm going to do this in pink. Let's say we were reflecting over this line. And let's say I have a box on this side. Hope y'all can see that. And a box on this side. The distance from the line of reflection to the original box should be the same as to the new box. Like this should be the middle of these two figures. So I need to find the midpoint of this segment. So the line of reflection you have to find the midpoint or the middle or the halfway point between all the distances. There's a connection between the line of reflection and the midpoint. So to find the midpoint, we add these two distances. So -4 plus 10. And then we're going to take that and divide it by 2. So -4 plus 10 is 6. 6 divided by 2 is 3. Okay, so it's the x value that changed, which means our which means our line is an x equals. We're going to have it be x equals 3. Okay, give me just a second. Okay, so we, just to double check this, I just want to make sure I didn't mess y'all up. So we have a point located at -4, 5. So we're going to graph that here. And then we want to reflect it and it land at 10, 5, which would be right here. Okay, and we found the midpoint of that segment to be at x equals 3. So x equals 3 would be 1, 2, 3. So this is on the x-axis. So here's the line, x equals 3. Ooh, okay, that's a pale pink, but it works. Okay, and then we're just going to double check the distance. So this is 1, 2, 3, 4, 5, 6, 7 away. 1, 2, 3, 4, 5, 6, 7 away. Okay, so we're good here. So x equals 3 is in the direct middle. So that is the line of reflection. Okay, just wanted to double check that before I steered anybody wrong. All right. So let's look at part B. I'm going to switch colors because it's getting kind of crowded. All right, so if I take 3, -5 and flip it across y equals 1, where is it going to end up? So we can graph it, and then I can show you some little mathy ways to do it. So y equals 1. That's a horizontal line that's going to go through here. So it's going to be across this line. All right, so the point is 3, -5. So 3, 0, 1, 2, 3, 4, 5. Okay. All right, so this is 1, 2, 3, 4, 5, 6 away from the line. So I need to go 6 even further. So 1, 2, 3, 4, 5, 6. Which would be at 7. So this would be at 3, 7. So this would be at 3, 7. Okay. So let's okay. So I had to think about how I wanted to do this. All right, so a good way to do it mathematically is let's take these 2 points and we're going to subtract them. Okay? So let's take the line of reflection, which is 1, minus the point, -5, and that's going to equal +6. Do you remember how we found the midpoint by cutting it in half? Like we added and cut in half? Well, to get the end point, we're going to subtract and multiply by 2. So that's 6 times 2 is 12. Now take that 12 and add it to that -5. We're going to add it to this point so we can see where it's going to end up. So plus -5 equals 7. Personally, I would take some graph paper and graph it. Just that's how I would do it. Okay. All right, so C, we have a point located at 6, 0. What is the image after a reflection across the x-axis? So this is fun. So 6, 0. That would be 3, 4, 5, 6 right here. 6, 0. Okay, if I want to reflect it over the x-axis, so if I want to flip it over here, well, that's not going to do anything because it's on the x-axis. So a point that is on the line of reflection is not going to move. So this is going to stay 6, 0. Now, if it had asked across the y-axis, if we flipped it across the y-axis, even though this is on an axis, it would still move over to this side. So just be careful. Again, I would graph that. Okay, I am skipping 8 because this is just practicing transformations and writing them in the notation. So I'm going to leave that. I have confidence y'all can handle that. Okay. So lines of reflectional symmetry and angle of rotational symmetry. So we talked about reflectional symmetry. We talked about rotational symmetry. I know you can find the lines of symmetry. That is where we draw through and see how many times you can flip over that line. But we did not talk about the angle of rotational symmetry. Now, I remember doing this last year, and in my whatever state of mind I was in this week, for some reason I thought that I was being extra teaching that last year, so I took it out. And I look at the quiz and I'm like, oh no, that was not extra, that was necessary. So what we're going to do is we're going to take our patty paper. And so first off, we know, we already talked about the isosceles triangle. It doesn't have rotational symmetry. So we're going to put 0 here because it doesn't have rotational symmetry. It does have a line of reflectional symmetry. I can flip it right down the middle. I can flip it over this line. So it's got one line of symmetry. There's no other line that I can put it on and it looks the same. Equilateral triangle, we actually talked about, well, maybe not this one. We talked about this one and there were 3. It goes, you know, a line through each vertex. I hope this is in the middle enough. It's just gonna have to do. Okay. So this should be the 3 lines of symmetry. Now, rotational symmetry. We know we can turn it, right? So, what I want to know is how many times I have to turn it, or what the angle is that I have to turn it by to get, like how many degrees I have to rotate it for it to be symmetrical. So what we're going to do is here's my center. I'm hoping that's center enough. And again, I can measure with a protractor. I really don't want to because that's kind of a pain in the butt. And we're going to rotate. Okay, so I'm hitting this. Whoop. There we go. So look, I hit it after 1 rotation, 2 rotations, and 3 rotations. So I rotated it 3 times. Or I was able to, y'all saw that. It took me 3 times to get back to start. So, how many degrees is that? Well, a full circle is 360. All right. And I want to know and I was able to rotate this 3 times. So, 360 divided by 3 is going to equal 120. Now, this was the center that we measured it from, right? I'm going to use my protractor to kind of guesstimate it. Now, this isn't perfect. I'm actually going to extend this line a little bit. And we are going to measure from this vertex to this vertex. Okay, so I'm going to make sure that this little line is on the vertex. And again, I did not, there we go. Yeah, that looked really rough. Okay, I've got 125, but this also was not very perfect. Miss Gallant does not draw things perfectly. And that ended up being 125 too. Wait. Okay. Yeah, that ended up being 125 too. I bet you if... Wait, let's see about this one. Let's see about going this way. Woo, and going this way, that ended up being like 115. So that, yeah. I didn't draw it very perfectly, but it's close to 120. So Miss Gallant can't draw. We already know this. But our rotational symmetry should be about 120. So let's look at a rhombus. Now we had how many lines of symmetry? We know we can go through the diagonals, but we can't. So we've got the diagonals, bloop, but we can't go through the sides. It doesn't work out that way. So I'm going to, let's sketch this one. And I'm going to put a star here. And that's going to be how we know we got back to center. Okay, so I'm going to rotate it. Okay, 90 degrees. Doesn't work. Okay, 180 degrees does. So we hit it once. And then we go back to center. So we hit our rhombus twice. We landed on it twice. So we have 2 lines of reflectional symmetry, and we rotated twice. 360 divided by 2 is 180. And that kind of made sense, right? When we twisted this, we twisted 180 degrees, full, like half a circle, and it went down. So we're good there. Okay. And actually, let's look at this. We only hit it once. 360 divided by 1 is 360, so we have to spin it 360 degrees for it to land back on itself. 360 and 0 are kind of the same thing here. All right, regular hexagon. So I know I can fold it down the middle. Ooh, that was an ugly cut, but you know, it is what it is. Let's see. I can do between these two sides. It's not great, but that was better. Between those two sides, that's okay. And I can also go in between all the, or from vertex to vertex. Okay, because I can fold from corner to corner and it match up. Ooh, that, okay, not very pretty, but you get the idea. Okay, so we had 6 lines of reflectional symmetry. Now let's look at rotational. Okay. All right, so I'm going to put my point in about the center. Ooh, and let's get a star going. So I'm going to put a star on top so I know where I'm at. Okay, let's spin. 1 matches up. 2, 3, 4, 5, and 6. So we had 6, it matched up 6 times when we spun it 360 degrees. 360 divided by 6 is 60 degrees. Now I want you to notice something. Every time, so this one we had no rotational symmetry. We had 1 line of reflectional symmetry. 360 divided by 1 is 360. We could hit this triangle 3 times when we spun it, and we had 3 lines of reflectional symmetry. When we rotated, we hit our rhombus twice, 2 lines of reflectional symmetry. So here's our rule. We didn't, I wish we had spent some time on this in class, but it didn't happen, and I'm sorry. But this is how you get your angle. You take the lines of reflection, or I'm sorry, you take 360 and divide it by your lines of symmetry. All right. Okay, so number 10 is, let's see. Let me see if there's any I want to work on 10. Give me just a second. Okay, so there are 2 that I do want to talk about. And let's do B and C. Now, all of these, I feel like you need to practice, but we're going to do B and C together. Okay, so for these, now if I were rotating around the origin, that would be great. But we want to rotate with the tip of the arrow pointing at specific points. So let me grab another piece of patty paper. And we want, so look for B, we want my arrow pointing left. So we want our shape to look like this. And we want the tip to be right here at point 1, 2. So we want, see, that's 1, 2, 3. 1, 2, 3. 1, 2. So we want this shape. All right. So you can kind of trial and error this. So what I would do, let's start at the origin and let's rotate. So let's start, well, actually, yeah, that one actually worked out. I don't know, I think I was thinking something different. So that one worked out. Oops. All right, that one works out. And let's look, let's count from the origin. This goes down 1, and to the left, I'm sorry, and to the right 2. And we want it pointing left, so that's going to go this way. So we need to go up 2 and over 1. Up 2 and over 1. Okay, well that one worked out, so, but let's go ahead and write this. This is a rotation. We rotated it around the origin. Which way do we rotate? So we went from here to here. This is clockwise. Oops. Clockwise is negative, and we went 90 degrees. You could also do a positive 270. Okay, and we rotated the arrow. I guess we don't really need what we rotated because there's not really a name for it. Okay, let's go to C. So C does not work out as nicely. C, we want it pointing right. And we want the tip at 5, -2. So if we have our arrow pointing right, we're down here. We are not over here if we go about the origin. So I need to get closer here. So my center needs to be closer to this point. So I trial and error this. I feel like there is a better way to do this though. Okay, so yeah, I kept looking at it, and I think the best thing we can do is trial and error this. So we do know that if I rotate around the origin, it's too far away. It needs to be closer to the right. So let's see what happens if I move this. Let's try 2 spaces to the right. That looks closer to the 5. So what happens here? Well, it also gets lower. So, which means I need to come up. So what happens if I come up? Okay, it looks closer. Let's go up another. Okay, well now I'm up enough, but it's still not to the right enough. So let's go to the right some more. I'm going to go over to the right 2 more. Okay, well now it's too far down. It needs to come up. So, but I don't want it to go to the right anymore, so let's go up 1 and left 1. Oops, I'm sorry. After we do this, let's try right here. Okay, it's still too far down. So let's come here. It's too far to the right. Now it needs to come down. I'm getting too close to this. Okay. Boom, I think we got it. I think we got it. Right here, right here, right here, right here. That would be 3, 3. Okay. Okay. So I went ahead and I labeled this point. This is -2, 1, and we wanted it at 5, -2. And our center is 3, 3. So, let's see. And if you remember when we go, so this is going counterclockwise 90 degrees. So counterclockwise 90 degrees, which we take the X and Y, and we swap them and change the sign. So negative Y and X. Is that right? Yes, yeah, that's right. So counterclockwise 90 degrees. So we did swap our X, I'm sorry. So we swapped our X, and our Y we did, went from 1 to 5. And added 4 to. No, I'm sorry, added 2 to. We also made this negative. So I'm not sure. I keep thinking I'll find a connection, and we'll see. I know there's a mathematical way to do it, and I can post a link to that. The only way I know how to do it is overly complex. So, yeah. So anyway, we rotated around this point. This is 3, 3. The best way I know how to do it is trial and error. And we may have, I will say the only one of those I see, or I only see 2 of those, okay? And you'll be okay. The best way I know how to do that is trial and error. So just to write this, we rotated around the point 3, 3. And we did that 90 degrees counterclockwise, so just 90. And yeah, there we go. I'll let you try the other 2 on your own, but the best way I know how to do it is trial and error. And I hate that that's the best way I know how to do it, but it is. So the one thing I can say is, remember, you can actually rotate on the figure itself. So if like the tip is in the same place, or if the base is in the same place on the arrow, that's kind of a hint that the center of rotation is on the thing itself. Okay. All right, compositions of transformations we are going to worry about Monday. We're going to write those. All right. Number 12, describe each composition of transformations as a single transformation. So we are going to work on this a little bit, but I'm going to go ahead and film this. So let's look at number 12. This says we are going to, when we read a composition of transformations, we start on the inside and work our way out. So the first thing this says is that we're going to reflect across x equals 0. Then reflect across y equals 0. So if I want to reflect across the x and the y axis, let me get my coordinate. So here's my x and y axis. We'll just do it here. Actually, no, before I do that, let's do this. Let me do it on a sheet of paper. Okay. If I want to reflect across the x and y axis, so let's say I have a square here. Actually, let's make it a house. Let's make a little house. If I reflect across the x axis, then that should look like this. I am just spitballing. And then if I want to reflect across the y-axis, that's not going to change. That's going to, well, it is. It's going to change position, but it's going to look like this. So what's something I could do instead of reflecting twice? Well, let's look at this. What happens when I rotate it 180 degrees? The thing that was here is now here. So rotating 180 degrees does the same thing as reflecting across both axes. So let's write that in blue right here. So we could, instead of reflecting, we can rotate 180 degrees around the origin. And if I want to write it in our notation, that would just be rotate around the origin 180 degrees. And you can do clockwise or counterclockwise. I don't care. Okay, part B. So this is a rotation. So we're going to start with the center and work our way out. So we are, for B, we are rotating 45 degrees, 45 degrees counterclockwise, then 90 degrees clockwise, and then 90 degrees counterclockwise, and then 90 degrees counterclockwise. So we are rotating back and forth and back and forth. So let's look at this. We are going 45 counter, and then 90 clockwise, and then 90 counterclockwise. Well, that negative 90 and that 90 are going to undo each other. And then we are going 90 more degrees counterclockwise. So for our rotations, if we're just rotating over and over and over again, you can add up all your degrees. So really, we are rotating 45, we go back 90, so we're at negative 45, we go back 90. So now we're at positive 45 again, and then we go at 90. So 90 and 45, that is 135 degrees. So really what we just did was a 135 counterclockwise rotation. Okay, so we're going to say we are going to rotate around O 135 degrees. So just add your degrees. Okay. Translations it's basically the same thing. We are adding where we're going. So basically this translation says we're going to go to the left 3 and up 0. Now we're going to go to the left and right 0, but we're going to go up 4. Now we're going to go to the left 2 and up 1. Now we're going to go up 1. Now we're going to go to the right 6 and down 1. So what we're going to do, let's take all our x's. So negative 6, 0, negative 2, 0, and negative 3. So negative 6 plus 0 is 6. Oh, that's positive 6. I'm sorry. 6 plus 0 is 6. Minus 2 is 4. Plus 0 is still 4. Minus 3 is 1. Yeah. Okay, for our y's, and yes, I did say start on the inside and work your way out. I know I added that backwards, but addition is commutative, so we are okay. We'll be fine. It works out the same. 0, now we'll say, when you perform these rotations, if you translate then reflect, it's not the same as reflecting then translating. So when we actually do the compositions, please be careful about that. Okay, so looking at this, we're going to do 0 plus 4 is 4. 4 plus 1 is 5. 5 plus 1 is 6. 6 minus 1 is 5. So we can either do all 5 of these translations, or we can combine our x's and combine our y's and get one basic translation. Okay, and the last thing I'm going to do, this page I think you can handle. The last thing I'm going to do, and I'm only going to do C. So I think y'all can handle A and B and I'm going to do this in class as well. And this is finding the inverse of transformations. I scratched it out because I thought I was going to do something different, but this is actually pretty useful. So So what we're doing is trying to find the function that will undo this. So if I take a figure and I rotate it around the origin, 90 degrees counterclockwise, and then I reflect it over the line y equals 2, and then I translate it -5 to the left and 3 up, how do I undo all those transformations? So basically, we're going to write this backwards. So what we're going to do is, since we started with the inside, when we undo everything, so if I want to undo it, we're going to start with the last thing we did. It's just like clicking the undo on Microsoft Word or Google Docs, whichever one y'all use. So you've typed stuff, and then you hit undo, and it gets rid of what you typed, and then you hit undo, and it gets rid of the thing you did before that. Same thing. So we did, this was step 1, step 2, step 3. So when we undo it, we're going to go backwards. Okay, if I went 5 to the left, how do I undo 5 to the left? Well, undoing 5 to the left would be doing 5 to the right. How do I undo 3 up? By going 3 down. And we just undid the translation. Okay, let's put that in parentheses. Because now we're going to undo the step before that. So we reflected over y equals 2. So if I reflect something over y equals 2, how do I undo it? Well, by reflecting it again. If I take something and I reflect it over this pen, well, how do I undo it? I reflect it back over, and it goes right back. So reflections don't change, so that should be easy. So we're going to leave that the same. And then the last thing we do, well, how do I undo going 90 degrees counterclockwise? By going 90 degrees clockwise. We just go backwards. How do I write clockwise? Well, I just change my 90 to a -90. Okay, and that's really tight and ugly, so let's try this again. Let's just rewrite this. So we're going to take what's on the inside and undo it. We're going to take the next piece and undo it, which with a reflection is just performing that reflection again. And then we're going to take that translation and undo it, and now look, it's nice and pretty because I took my time. And we're good. Okay, so Monday we are going to work on composition, which is where we basically, hey, let's take this object, translate it, and then after we translate it, let's rotate it. And then we're going to go back and undo it this way. And we don't actually have to undo it, we're just writing it. So I want you to try A and B. I will have the key posted for you to check your work. I know this was an hour long, but I hope you found it helpful. And so yeah, I just hope this helps you guys out. I'm so sorry that like this week has been kind of a cluster, but next week will be better. So thank you guys for your attention. I hope you have a great day, and I will see y'all Monday.